Hello again, Algebra 2 class. This set of videos is going to cover Chapter 7, Section 1 from your Algebra 2 textbook. That section is on permutations and combinations. We have two main objectives in these videos. The first is to solve problems using the fundamental counting principle, and the second is to solve some problems using permutations and combinations. All of this is really just a fancy way of saying we're going to be doing some counting. This first video is going to cover the fundamental counting principle, and it's easiest to just jump in with an example. Mr. Steady has two ties, a red one and a blue one. He also has three shirts, a striped one, a checkered one, and a polka dotted one. How many different combinations of ties and shirts does he have? So one way we can analyze this problem is by actually just drawing out all of the different possibilities. So if we kind of start off the beginning of the day, we can go from there and say, okay, well, he has two choices first, the red tie or the blue tie. And then if he picks the red tie, here he has three choices after that, the striped shirt, the checkered shirt, and the polka dot shirt. He has the same three choices if he wears the blue tie. He can have the striped shirt, the checkered shirt, or the polka dot shirt. If we go ahead and look at this bottom row, we can see he really has six total options, right? The red tie with the striped shirt, the red tie with the checkered shirt, red with polka dotted, etc. So he has six total different outfits. Now, some of you at the beginning might be thinking, well, yeah, that makes sense because he has two ties, and for each tie, he has three different shirts he can wear. So that's just 2 times 3 is 6. And that's actually exactly what the fundamental counting principle says. To expand a little bit on that, the fundamental counting principle says if we have multiple items to choose, and there are A ways to choose the first item, B ways to choose the second item, C ways to choose the third item, and so on, then the total possible number of ways to choose all of the items together is just A times B times C, and so on. So what does that look like in a slightly more complicated example? Well, in Utah, a license plate consists of 3 numerical digits, so the numbers 0 through 9, followed by 3 letters. The letters I, O, and Q are not used, and repeats are allowed. So you can have 888 as your number, for example. We want to figure out how many different license plate combinations are possible. So one way to think about this problem is we really have 6 different items to choose, right? Because there are 6 different characters on the license plate. For the first 3, we have to fill it in with a digit, which means we have 10 choices for this item, 10 choices for this item, and 10 choices for this item. For the last 3, well, there are 26 letters minus the I, O, and Q that we can't choose, so that's 23 choices. So we have 23 for this item, 23 for this item, and 23 for this item. Now, the fundamental counting principle says that if we have a bunch of items to choose from, and we know how many choices we have for each item, then we can just multiply all of those together to get our total possible arrangements for these license plates. And that's exactly what we end up doing in this problem, is we just multiply all of these numbers together. And if you do 10 times 10 times 10 times 23 times 23 times 23, right, do all of this multiplication out, you end up with 12,167,000 possible combinations. One more example. So let's say you go out to eat at a restaurant and you can, for your meal, pick 1 entree, 1 side dish, and 1 drink. And this is their menu, right? You have 3 things to choose from for your entree, 3 from your side dish, and 3 from your drink. If we go ahead and start to think about this, this is really another fundamental counting principle problem. Because we have 3 items to choose, an entree, a side, and a drink, and we have a certain number of choices for each of those. So to find out the total possible number of meal combinations, we just multiply all of these together. 3 times 3 times 4 comes out as 36 total possible different meals.